Good morning. Thank you for joining us this morning for the second episode of the JFT Coffee Break webinar series. So I see we have some attendees from last week that came back. So thanks for coming back and joining us. And there's also some new names here that I don't recognize. So for those that don't know me, my name is Scott Adams. I'm the CEO of James Fisher Technologies. So I think as we saw from last week, I'm sure our attendees list will grow over the next couple minutes as people figure out their Zoom links and figure out how to join in. But we'll go ahead and get started. We do want to be conscious of time. We consciously set this up as a 20-minute coffee break because we know you guys have busy schedules, things that are important to get to, and we want to make sure that we are are conscious of that as we go through this. But by way of introduction, for those that didn't join us last week, James Fisher Technologies is a technology firm based out of Colorado. We are focused on providing engineered systems that make the workplace safe for workers and the public. So we provide things like robotic systems, remote systems, and today and for this series, we're focused on our safety systems used in the construction industry. So today I am joined with Nigel Shaw. So good morning or good afternoon, Nigel.
Good morning, Scott. Yeah, and thanks for having me on here. Very much appreciate that, and pleased to be part of this.
So Nigel is the general manager of Prolec over in the UK, and he's joining us for our episode today, and will be giving us some neat information about their safety systems and what they're doing. Nigel, would you like to give us an introduction to your company, to James Fisher Prolec?
Sure. Yeah, so we were set up maybe about 15, 20 years ago. Our passion is very much trying to solve issues in construction sites with dealing with hazard mitigation, looking at problems that the industry needs solving, make the place safer, and also try to pull new technology into this environment. There's a lot of good technology. There's a lot of cool things out there. And we're looking at trying to use those to ensure that construction sites are safer places, that they are safer, more enjoyable places to work. And that's what you're going to see. You're going to see some of our cool tech in the next few minutes, and show you what we can do, at least today, and hopefully that will help you all manage construction sites better.
Awesome. Yeah, and I guess to give a little bit of context, we started working with Nigel's team a little more than a year ago to bring these systems and their solutions into the North American market, and it's been a great run. I think we have a number of systems out. I think 9 systems right now on some of the largest infrastructure projects going in the U.S. So there's definitely a need for them in the U.S. market, and we've definitely seen a demand as we've started to get some more exposure of what's available and what they've got and what we're offering. So by way of recap for last week we had 2 individuals on, Blair Christensen and Mike Shea. So those gentlemen are working on 2 large rail projects, construction projects. One's in Boston and one's in Florida. And they are using our systems, Nigel's Prolec systems, on those projects. And we talked through how they were being deployed and what it was like to deploy them on a site. So we'll post that webinar so everybody can see that. But today, what we have the opportunity to do with Nigel is to go through a virtual demo. So this will allow us to show everyone what it's like to be an operator, to sit in the actual seat of an excavator and run these systems. So I guess, Nigel, before we jump straight into the video, what are we going to see today?
So what we've got, what I quite like, is that we're actually going to see something I know we're going to see, rather than when we often run these videos or demos that actually you can't quite predict the future. Well, actually we can predict the future for this one. What we're going to see is a view of both the operator's perspective of the solution, so what the operator sees when they're using the machine, when they're using our solution. And we're also going to see that from an external perspective, so what a site supervisor might see. And with those two viewpoints, we're going to then look at how this solution can help mitigate hazards. We're going to see our star of the show, Ed, driving the excavator. He's going to be setting some height limits to prevent the machine going too high. He's going to be doing some swing limits and some slew limits and some virtual wall or e-fence limits. And we'll have a bit of a chat about why he might be doing that as we go through that.
Oh, cool. Yeah, and I guess one thing that I do need to make sure that I mention here is that as we go through this video, we do have questions coming in. So there's a question icon down at the bottom of your screen if you're using Zoom. You can just pop a question in through the Q&A section there. Mark Slauson, again, will be keeping track of those and popping those in as we go through the video or after the video. And then feel free to email questions to Mark as well for those that are on the phone. So I guess with that, Nigel, let's go ahead and Tom, it looks like you have the video up and running ready to go. So yeah, Nigel, let's go ahead and get started.
Brilliant. So we'll start the video. We're off there. So the machine is starting. So we're going to look at as you say, both the operator's perspective and the site supervisor's perspective. That's our screen there. So you can see that's what the operator will see. We're just going to pause on this screen for a moment, just to get a view of what information is provided to the operator. Just quickly looking at this screen, on the left-hand side there, you can see a visual representation of the excavator. This is a two-part excavator, so you've got a boom and an arm, but we also support what we call triples, so boom, artic, and arms. There's two little green arrows next to each articulation there, and they're both green, which means the operator is able to articulate those in both directions at this moment in time. So it's a very quick indication of what our system's providing from a limitation perspective. On the right-hand side of the screen, we've got an overview, and you'll see this take shape as we go through this demo. You'll see more information displayed there. You can see from an operator's perspective, it's very clear what they're seeing there. There's the tracks of the machine, there's the articulations, and as the machine rotates, that rotates live to give them very much reassurance that the system is working, and also ensuring that they understand what that's displaying. So I'm going to let Tom run the video for a bit further, and we'll see some more screens. There's our star of the show, Ed, and he's oh, he never realized he'd be broadcast to the States when he did this. So there's just some indication of how the machine is operated. There's the solution's operated. There's 6 buttons. You don't need to pay too much attention to this, other than the buttons are controlled by just simply touching them. You can wear gloves to control these buttons, and that allows the operator to be in a very realistic working environment. And we've got these solutions deployed in thousands of machines in many different environments. So we'll just let Ed prepare himself for the next stage here.
Nigel, is that our sensor there that I see mounted on the boom?
Certainly. So we understand the position of the machine by having angle sensors attached to the articulations of the machine. These are highly reliable, very highly ruggedized sensors that you could drive literally, and we've tested this, drive a truck over. But what they're doing is measuring the angle accuracy down to 0.2 degrees that allows us to get the level of safety that we need. Now, what we're seeing going on here is Ed actually turning a key switch. There are 2 key switches there. This allows him to now make changes to the settings on his machine. So the one on the left, you can almost see the word limit there. That allows him to change the limits of the machine, and we're going to see him do that in a minute. The one on the right is actually an emergency measure that allows a site supervisor to override the safety system in the event of an emergency. Both these switches are available in the machine at the moment, but they could be removed and the authority of using those switches given to anyone else on site. So I think we're going to let Ed go and set his limits. So Tom, if you could release his lock there, and he's now going to go through and set the limits. So I'll talk you through this and catch up in a minute. But he's effectively going to do, through a number of ways, set some height limits. A height limit is simply, not surprising, there to prevent the excavator from reaching some sort of hazard. So there's some sort of hazard mitigation going on here. That might be to limit the machine's movement from hitting a tunnel, a bridge, or more than likely some sort of overhead cable. So we have these used in the UK, and we've got 400 kV cables across most of our highways. And the last thing you want is what that giant conducting piece of metal to hit any of those high voltage cables. So we'll just let Ed play a little bit further. So what Ed was doing there was he was setting the height limits by dialing in a specific height, which on this screen was in meters. We also support feet and inches, so it suits whatever environment that it's deployed into. Now, there are two ways to set the height limits. As you can see, you can dial in the exact height, and that's the height above the base of the tracks of the machine. If you have a site height limit, then that's something you can easily enforce across the site. If you don't have that level of information about the site, the other thing we saw Ed do there was actually to raise the machine to a point and then instruct the machine to not let instruct the solution not to let the machine go any further past that point. So that allows him to easily set the height limit, and again now never breach that limit. So I think we're probably then done with Ed on the height limits. I think if we release him, we're going to start looking at some swing limits now on the machine. So certainly, so Ed's now setting the swing limit on the machine. This is the basic form of limitation for controlling the rotation or the swing of the machine. What he's going to do is he's going to move to the leftmost part of what he would consider his limit. He's going to mark that point using our system simply by pressing a button there. Then he's going to swing to the rightmost part of the limit and press another button. And that's setting an angular limit, which on this screen is probably about somewhere between 40 and 60 degrees. And that's going to restrict the movement of the machine from only operating within these two limits. When you set that, you're going to see the main screen update so that your operator's got a very clear indication of what that limit has been, what limit's been enforced there.
So these are the pie-shaped limits.
Absolutely, yeah. So these are less commonly used in the industry because generally your hazards aren't pie-shaped. So what that allows you to do is really restrict the machine's movement. Perhaps you're concerned about the machine operating over the rear of the tracks. So in this instance, that would be ideal. It would prevent Ed from using the machine over the side or over the rear. And you can see there that when those red lights flash, that's an indication to Ed that he's reached the limit. Now, as I say, the hazards aren't often wedge-shaped or pie-shaped. Most hazards are walls and straight things or things that are outside of the cab. So what we're going to see Ed do now is mark the position of a wall or an e-fence, depending on what terminology you prefer. So he's extending the machine out to a point, and he's going to say, I'm going to mark that as the first point on my virtual wall or e-fence. He's then going to swing round and mark another point further away in a line, and that line is going to create this e-fence or virtual wall that's going to now prevent his machine from slewing or swinging into that area. And this is the most common form of hazard mitigation we see. You use this against, we've got a wall there, and that wall could equally be a highway carrying live traffic or a railway carrying live trains. And by marking this area as he has done there, again, clearly shown on the screen, he now cannot move that machine into that hazard, thus preventing him in a live highway situation from accidentally slewing the machine into the path of any oncoming traffic.
So Nigel, I could imagine situations where you want two walls. Is it possible to set up two walls in your hazards?
Yeah, absolutely. Quite common. We might find ourselves working in central reservations, so in the middle of a highway or in the middle of a railway track, and actually the hazards are to both sides. So the next level of complexity, which we don't show here, would be for Ed to draw another wall, which would be as simple as the one we've seen him do. And that wall doesn't even need to be parallel to the one we've drawn here. He can effectively create a very complicated environment in which he can work. Traditionally, people don't do that. We tend to keep it simple. We need to keep it simple for the operators to use, but the functionality is certainly there for very complex situations.
Cool. All right. Well, that was a great demo. Nicely done. Thank you, Nigel.
It went exactly as I thought it would.
Well, good job, and good job to Ed. So
absolutely, I'll let him know.
So I guess we are coming up. We got about 4 minutes left before our 20-minute target. So what we'd like to do is just open it up to some questions. Mark, do you have any questions that popped in?
I do, actually. So the first question I had was, is there a way to protect the bucket from encroaching upon the cab? That's something that I get that question quite a bit from customers. So maybe Nigel can take that.
Yeah, no, sure. If you, I'll take that one. So Mark, absolutely. We have what's called cab protection. And it's if you imagine it as a virtual wall in the same way we've seen the ones on that demo, it's a virtual wall literally in front of the cab, and that prevents the bucket, which is part of our controlled environment, literally from moving in towards the cab. So yeah, absolutely, and that's a standard feature.
Awesome. All right, I got another one. So can the rear of the machine be protected on a non-zero swing excavator?
Brilliant. Another good question. I'm glad you asked that because we've put a lot of effort into this one. So excavators, we have a view of the excavator as much bigger than a kind of very small point swinging around on the machine. We have excavators that are much larger than the one you saw there, with counterweights on, even extending counterweights. And what we do is we understand the location of those as well as the location of the bucket. So where you have a machine with a large backside, for want of a better term, we can prevent that also from slewing into the path of any traffic or any hazards.
Sweet. I got a couple hot ones rolling through. So we were talking about the height and side-to-side limitations. What about the excavator bucket depth and reach?
So absolutely, again, we haven't gone to show that. The depth is a negative height, from want of a better term. But no, we can also prevent the bucket dipping down. That's quite commonly used where you've got underground hazards. So be it electronics, be it pipes, be it water, sewage, whatever. You might want to limit the depth. So yeah, absolutely, we can achieve that. Was there a second point there that I didn't answer? I think.
No, I don't think so. I think you got that. I've got a few more here. So what manufacturers are you currently installed on?
The quickest answer is what are we not installed on, and that's none. We are an aftermarket fit solution. We can install these on any type of hydraulic controlled excavator and some electronic as well. But it's a solution that we have designed to be able to fit to any type of excavator. The only limitation I'd say is size. Where you go down below 6-ton machines, you might start to find limitations with actually being able to install the physical hydraulics and electronics. But traditionally, 6 tons or above is quite normal for us.
All right, another one here. Can your system integrate to the lifting capacities of the machine?
Okay, I'm not sure what the question is referring to. We certainly have solutions that look at the weight on the bucket and allow the machine to ensure the stability based on the load on the bucket. That's something that that might be the answer to the question, in which case the question is absolutely yes. And that's used quite a lot in the UK, where we work on railway tracks and they're lifting 5-6 ton bits of track, and we need to make sure they don't fall off the track. So if that was where the question was going, then absolutely we can do that too.
Awesome. Another one here. Does this machine or this system store data?
Yes, again, interestingly, it almost segued to the last answer, relating to the UK rail industry. As part of meeting the standards there, we've had to make sure the machine logs the movements, logs the behavior of the operator. And so therefore, we actually have a recording on this device, accessible only in need of wanting to be able to reproduce an environment. We're actually recording what the machine is doing throughout its day.
Yeah, so another one here. Is there a notice that something is wrong and not to rely on the settings, say if the machine is experiencing some electronic issue?
Yes, so we have an amount of diagnostics on the machine that we're aware of. We can indicate those through the display, or sometimes even indicate them through an external lamp as well. And I think that was a question that came up last week, people asking about indicators. We've got the information. How that gets displayed to the site or to the site supervisor can often be a very bespoke thing. It's almost a personal thing for that environment, and we can work with the site to make sure that's an effective policy. I think that might have answered the question.
I think you're good. All right, so just a couple more here. Are you installed on cranes or on AWP?
So again, no. It's something that we've explored in the past, and we're always looking to try and improve those. One of the things that will come out of this series of webinars actually is our ambitions for the future, and looking at how we can not just look at the static hazards, as we've seen here. I've been talking about static hazards of highways or roads, but also start to look at the more dynamic hazards, and cranes and their swinging loads are definitely a classic case for that. So not at the moment, but watch this space.
Good deal. One more question that I have. Does your system work only on factory boom and arm configurations, or will it work with modified configurations such as an aftermarket lengthened arm?
So we will support all sorts of modifications. We've got the machine we saw there. I don't think it had what we call a bendy boom or a boom slew, but we certainly support those. We support machines with extending articulations. We support machines with slew on articulations, so slewing artics or arms. We can support many different combinations. So yeah, absolutely. And as you say, they're often aftermarket fitments, and we'll work with whoever's doing the conversion or whoever owns the machine to get that data into our system.
Perfect. Yeah, that's it on the questions, Scott, if you want to take it from here.
Yeah, that was awesome. So I guess, Nigel, looking to next week, what we focused on today was the operator-centric systems, where the operator is able to set these walls. Next week, we're going to be talking about the next generation of systems. So these are the systems that your guys are developing now that enable both IoT and GPS capabilities within the systems. Can you give us just a quick idea of what's possible with
what's to come? Well, it's really cool tech. I mean, this is what we're trying to do. We're trying to take a lot of the technology that's out there in various other industries and bring it to the construction industry and use it to support all you guys out there and making things more productive. But we're going to see some data solutions. We're going to see how data can help us, how site management can get fed into these systems automatically. We're going to start to look at operators and removing responsibility from them. One of the big things that we don't like to see from a philosophical perspective is, you know, giving more and more problems to the operators to solve. We're all about taking those away, removing operator workload and making their job of actually doing the fundamental work easier whilst we make their life safer and more productive. So we're going to start to see how technology and data is really going to help with that.
Excellent. Well, that should be a good primer for next week. So everyone, we will be doing one more webinar next week, same time, 11 o'clock Eastern. I guess this is 8 o'clock Pacific time. So feel free to join us again next week for the third episode of the JFT Coffee Break webinar series. And with that, I guess we'll sign off. So thank you everyone for joining.
Thanks, guys. Thanks, everyone.
Thanks, Nigel. Thanks, Mark.
Thank you.